Good morning everyone. So in this video we are going to learn the concept division algorithm for polynomials in the chapter Polynomials of 10th class. Okay. So first let us know division algorithm for numbers, then after we can go for division algorithm for polynomials. So now what is division algorithm for numbers? First let us consider two numbers. I want to consider 27 is one number, another number is some 4. So now divide this 27 by this 4. Then we can get another two numbers that are quotient and a remainder. So now divide 27 by 4. 4 6 are 24. The remainder is 3. 4 6 are 24. Remainder is 3. So this is called, this 27 is called dividend. 4 is called divisor. 6 is called quotient. 3 is called remainder. So now this 27 can be written as 4 into 6 plus 3. 4 into 6 plus 3. Nothing but dividend is equal to divisor into quotient plus remainder. Quotient plus remainder. This is called division algorithm. So first let us consider any two numbers and divide a number by another number, then we get another two numbers that are nothing but quotient and remainder. Now this dividend can be written as divisor into quotient plus remainder. The process is called division algorithm. Okay. In this I want to consider another two numbers. For suppose 18 and some 5. 5 3s 15. Remainder is 3. Another two numbers 20 divided by some 4. 4 5s 20. Remainder is 0. Another two numbers some 16 divided by 2. 2 8s 16. Remainder is 6. So if you observe in this, here the remainder is 0. Here the remainder is 0. Here the remainder is 3. And here the remainder is 3. This remainder is less than the divisor. This remainder is less than the divisor. That means if we divide one number by another number, then we get the remainder is either less than the divisor. Remainder is less than the divisor or remainder is 0. So remainder is, remember this point, remainder is less than the divisor or remainder, if the remainder is not equal to 0, then the remainder is less than the divisor or otherwise remainder is equal to 0. Again I am saying dividend is equal to divisor into quotient plus remainder. It is called division algorithm for numbers. Now coming to division algorithm for polynomials. Okay. So polynomials means in this we can take two polynomials. In this we can take two polynomials. Let p of x and g of x. Let p of x and g of x are any two polynomials. Then there exist unique polynomials q of x and r of x. Q of x and r of x. P of x and g of x are any two polynomials. Then there exist unique polynomials q of x and r of x such that p of x can be written as g of x into q of x plus r of x. P of x can be written as g of x into q of x plus r of x. Here I consider two polynomials. P of x is divided by g of x. Then there exist unique polynomials q of x and r of x. So this p of x can be written as g of x into q of x plus r of x, where this r of x, about conditions, r of x is equal to 0, where r of x is equal to 0, or this degree of r of x is less than degree of g of x. Degree of r of x is less than degree of g of x if r of x is not equal to 0. This is called division algorithm for polynomials. Again I am saying p of x and g of x are two polynomials. There exist unique polynomials q of x and r of x such that p of x can be written as p of x is equal to g of x into q of x plus r of x, where r of x is equal to 0, either r of x equal to 0 or degree of r of x, because we can compare the polynomials based on the degree. This degree of r of x is always less than degree of g of x when if r of x is not equal to 0. That means either r of x equal to 0 or r of x is not equal to 0. If r of x is not equal to 0, then degree of r of x is less than degree of g of x. This is called division algorithm for polynomials. Division algorithm for polynomials. So in this concept mainly we have two types of problems that I will discuss. That problems are based for 4 months we can get in final examinations. So I will discuss the two problems first, then after I will tell you some important points based on this division algorithm for polynomials. Okay, first let us see one problem. So how the problem they will ask? So they will ask like this: divide one of the polynomial p of x, some polynomial they will give, by another polynomial g of x, and then they ask verify the division algorithm. Divide p of x is a polynomial divided by another polynomial g of x and verify the division algorithm. Like that they will ask the problems. Let us see one problem. Here the problem is divide 3x square minus x cube minus 3x plus 5 by x minus 1 minus x square and verify division algorithm. So already we know what is division algorithm. Dividend is equal to divisor into quotient plus remainder. So okay. So let us consider this polynomial as p of x and this polynomial as g of x. Let p of x is equal to. So if they have given any polynomial, so compulsory you have to write that polynomial in the terms in descending order powers. So 3x square minus x cube minus 3x plus 5, it is not in standard form. You have to write that in standard form. So that means standard form is nothing but how to write the powers in descending order. Minus x cube plus 3x square minus 3x plus 5. Similarly, g of x also. G of x is equal to x minus 1 minus x. It is also not in standard form. How to write in standard form? Minus x square plus x minus 1. Okay. Now divide p of x by g of x. So minus x cube plus 3x square minus 3x plus 5. This one is g of x is x square plus x minus 1. So now we have to eliminate this minus x cube term. How can we eliminate? So by multiplying minus x square with another variable, then we get minus x cube. By which variable we need to get? We don't know. So that how to divide this minus x cube? Simply how to divide this minus x cube by this minus x square. Then we get the quotient. That is nothing but minus x cube by minus x square. This term, this first term, is divided by this first term. So minus get cancelled. X cube by x square. It is in the form of a power m by a power n. Nothing but a power m minus 1. X power 3 minus 2. X power 3 minus 2 nothing but x power 1. Nothing but x. So how to multiply with x? Now we have to multiply this total expression by this x. So now minus x square into x minus x cube. Minus x square into x minus x cube plus x into x plus x square minus 1 into x minus x. Now change the signs. Plus, here plus means you have to change minus, minus means plus. Then these two get cancelled. Minus x cube plus x cube get cancelled. 3x square minus x square. Nothing but 2x square. Minus 3x plus x. Minus 3x plus x minus 2x plus 5. Now again you have to eliminate this 2x square. Eliminate this 2x square. How can we eliminate? Divide this 2x square by this first term. 2x square is divided by minus x square. X square get cancelled. 2 divided by minus 1. 2 divided by minus 1 is nothing but minus 2. Minus x square into minus 2, 2x square. X into minus 2, minus 2x. Minus 1 into minus 2. Minus 1 into minus 2, plus 2. So this is minus, this is plus, minus. Then these two get cancelled. Minus 2x plus 2x also get cancelled. 5 minus 2, 5 minus 2 is 3. See here what we get. This is the quotient x minus 2. This is the remainder 3. So remainder is 3 here. It is what? Constant. Degree of constant polynomial is what? Degree of constant polynomial is 0. Degree of constant polynomial is 0. Here the degree is 2. So if we observe degree of r of x is less than the degree of g of x or not? Degree of r of x is less than degree of g of x. Degree of constant polynomial is 0. Degree of this polynomial is 2. So degree of r of x is less than degree of g of x. Okay. So this is about division. Now verify the relationship. So here already p of x, this is g of x. Let us consider this is as q of x and this as r of x. Q of x is equal to x minus 2. R of x, here we get constant now, so that r of x is equal to r is equal to 3. So let us consider that r as constant as r of x equal to r is equal to 3. Now we have to verify the division algorithm. Nothing but we have to verify p of x is equal to g of x into q of x plus r of x or not. So let us consider g of x into q of x plus r of x. So we have to equate this to p of x. It will equal or not. Now we have to verify. What is g of x? This one. Minus x square plus x minus 1 into. What is q of x? X minus 2. What is r of x? 3. Now multiply with this. Minus, how to multiply? Minus x square by these two terms. Minus x square into x. Minus x cube. Minus x square into minus 2. Minus into minus plus x square into 2. 2x square. X into x. X square. X into minus 2. Minus 2x. Now minus 1 into x. Minus x. Minus into minus plus 2. Minus into minus plus 1 into 2 plus 3. That is equal to minus x cube plus 3x square. 2x square plus x square. 3x square. Minus 2x minus x. Minus 3x. 2 plus 3, 5. So see, minus x cube plus 3x square minus 3x plus 5. This is nothing but p of x. Therefore, clearly we can write p of x is equal to this. G of x into q of x plus r of x. So here r of x is not equal to 0. It is a constant polynomial. The degree of constant polynomial is 0. So degree of r of x is equal to degree of r of x is less than degree of g of x. Hence division algorithm is verified. This is about if they have given problem like this and verified division algorithm. You can write, you can solve like this. Compulsory you will get 4 out of 4 marks. So from this we can write some important points that are. So I want to remove this. See, here one first point is, here this is p of x. It is p of x and it is q of x, it is g of x, it is r of x. Okay. So what is the degree of p of x? Degree of p of x is 3. Degree of p of x is 3. So degree of p of x is 3. Here degree of g of x is 2. Here the degree of q of x is 1. So degree of p of x can be written as degree of g of x plus degree of q of x. The first point is degree of p of x is equal to degree of g of x plus degree of q of x. First point is degree of p of x. Here degree is 3, here degree is 2, here degree is 1. So degree of p of x is nothing but 3. Degree of g of x is 2. Degree of p of x is 1. 3 is equal to 2 plus 1. So the generalized formula is degree of p of x is equal to degree of g of x plus degree of q of x. And from this, if degree of sometimes if they have given g of x as linear polynomial, degree of linear polynomial is 1. So if degree of g of x is equal to 1, then this implies degree of p of x is equal to degree of g of x plus degree of q of x. Sorry, degree of p of x is equal to 1 plus degree of q of x. This is first point. Second one is, it is a p of x. If here they have given a linear polynomial. Linear polynomial is considered that as x minus a. If p of x is divided by x minus a, p of x is divided by x minus a, then the remainder is p of a. Simply we can write p of x is divided by x minus a, then the remainder is p of a. Let us consider p of x is equal to one polynomial x cube minus 3x square plus 2. This is one polynomial. If it is divided by some x minus 2 or x plus 2, x minus 2 or x plus 2, so they ask to find the remainder. So nothing but p of minus 2. You can calculate p of minus 2 is nothing but remainder. A p of, here they have given x minus c means remainder is p of a. X plus c means remainder is p of minus a. So here minus means you have to write plus a, plus means write minus a. Simply x minus a, take x minus a equal to 0, x equal to a. X plus a equal to 0, then x equal to minus a. You have to take simply like that. So divided by x plus 2, then p of minus 2 is equal to minus 2 whole cube minus 3 into minus 2 whole square plus 2. Minus 2 whole cube is nothing but minus a. Minus 2 whole square 4. 4 into minus 3 minus 12. Plus 2. So nothing but this is minus 20 plus 2 minus 18. So remainder is minus 18. So here the point is, if p of x is divided by x minus a, then the remainder is p of a. This is one point. And one more point. If the remainder is 0, that means if the remainder is If the remainder is 0, then we say that this g of x is factor of p of x, as well as this g of x is factor of p of x. Let us see. I want to consider 6. 6 is divided by 2. 6 is divided by 2. 2 3 is 6. Here what we get? Remainder is 0. So that we can say 2 is the factor of 6, as well as 3 is the factor of 6. 2 is factor of 6, 3 is factor of 6. Like that. Here also, if the remainder is equal to 0, then g of x is factor of p of x, as well as q of x is factor of p of x. The remainder is 0, then g of x is factor of p of x, and q of x is a factor of p of x. Factor of p of x. These are the important points. So degree of p of x equal to degree of g of x plus degree of q of x. And if p of x is divided by x minus a, then the remainder is p of a. If the remainder is 0, then g of x is factor of p of x and q of x is factor of p of x. These are the three important points based on divisional algorithm. Okay. And next, let us see one more important problem for 4 marks. That is, so like this they will give a problem. Obtain all other zeros. Obtain all other zeros of 3x power 4 plus 6x cube minus 2x square minus 10x minus 5. If two of its zeros are root of 5 by 3 and minus root of 5 by 3. So here if we observe, they have given one biquadratic polynomial. Already we know biquadratic polynomial has at most 4 zeros. Here they have given 2 zeros, then they asked to find all other zeros. Already they given 2 zeros. Now we have to find other 2 zeros by using these 2 zeros. So solution is, let us consider given polynomial as p of x. So here all the terms are in, powers are in descending order only. It is in standard form. P of x equal to 3x power 4 x cube plus 6x cube minus 2x square minus 10x minus 5. Okay. So already we know if alpha is 0 of p of x, if alpha is 0 of p of x, then x minus alpha is a factor of p of x. If alpha is 0 of p of x, then x minus alpha is a factor of p of x. Here given zeros are root of 5 by 3 and minus root of 5 by 3. So root of 5 by 3 and minus root of 5 by 3 are the given zeros. So these are the zeros, means which are the factors? X minus root of 5 by 3 and x plus root of 5 by 3. So plus means we have to write minus, minus means we have to write plus simply. Or the factors of p of x. So we need to get other 2 zeros. By multiplying this one, we can get one polynomial that we have to consider as g of x. So now divide p of x by g of x, then we get one quotient. So that quotient zeros are nothing but zeros of this polynomial that we have to calculate now. Now let g of x is equal to product of these two polynomials. So x minus root of 5 by 3 is a factor of p of x, x plus root of 5 by 3 is a factor of p of x, then compulsory the product of these two polynomials are also factor of this polynomial. So x minus root of 5 by 3 into x plus root of 5 by 3. If you observe, it is in the form of a minus b into a plus b, a minus b into a plus b. The formula is a square minus b square, x square minus root of 5 by 3 whole square. Root, if we remove it, then we get whole power 1 by 2, 2 get cancelled. Then simply we can get x square minus 5 by 3. Root and square get cancelled, x square minus 5 by 3. This is g of x. It is the factor of p of x. X plus root 5 by 3 is also factor of p of x. The product of the two polynomials is also factor of p of x. Nothing but x square minus 5 by 3 is the factor of p of x. If it is the factor of, that means it is nothing but g of x. G of x is the factor of p of x. G of x is the factor of p of x. Then what we get the remainder? The remainder is nothing but 0. It is the factor of p of x. So the remainder must be 0. So then q of x, see, p of x and g of x. G of x is the factor of p of x. Then compulsory we get the remainder is 0. G of x is factor of p of x, then we get the remainder is 0. Then here we get one quotient, remainder is already 0. So that q of x is also factor of 0, factor of p of x. By finding the zeros of this q of x, we can get some zeros. That zeros are nothing but zeros of p of x also. That zeros are nothing but zeros of p of x also. That we have to discuss now. So now divide this polynomial p of x by this g of x. So see, 3x power 4. Now divide p of x by g of x. 3x power 4 plus 6x cube minus 2x square minus 10x minus 5. So here it is x square minus 5 by 3. Already we discussed how to divide the polynomial by another polynomial. First we have to eliminate this 3x power 4. How can we eliminate? Divide this first term by this first term. It is 3x power 4 by x square. So nothing but 3 into x power 4 minus 2 to 3x square. Or simply x square, 2 will cancel, 3x square. So 3x square. X square into 3x square, 3x power 4 minus 5 by 3 into 3x square minus 5 by 3 into 3x square. Multiply that 3 get cancelled, then we get minus 5x square. Minus 5x square. Now how to write this minus x square term below the minus 2x square term? Now to write under the x square term itself. Minus 5x square. Here there is no x cube term, so how to keep minus 0. Now change the signs. Minus plus 3x power 4 minus 3x power 4 get cancelled. 6x cube minus 0, nothing but 6x cube. Minus 2x square plus 5x square, 3x square. Minus 10x minus 5. Now you have to eliminate 6x cube. Again divide 6x cube by this x square. 6x cube by x square. So x square term, cube term get cancelled. We can get 6x. 6x. Now multiply. X square into 6x. 6x cube. Minus 5 by 3 into 6x. Minus 5 by 3 into 6x. 3 ones, 3 twos. Minus 2 into, minus 5 into 2x is nothing but 10x. Minus 10x. So write minus 10x under x term. Minus 10x. Here there is no x square term. So let us keep as 0. Now change the signs. Minus plus. These two get cancelled. 3x square minus 0 is nothing but 3x square. Minus 10x plus 10x. This also will get cancelled. Minus 5. Term is minus 5. Now again we have to eliminate 3x square. So divide this 3x square by x square. 3x square by x square. X square get cancelled. Then we get the quotient is 3. So x square into 3. 3x square. Minus 5 by 3 into 3. Minus 5 by 3 into 3. How to multiply each and every term of this expression by this 3. Minus 5 by 3 into 3. 3 get cancelled. Then we get minus 5. Minus plus. These two get cancelled. Remainder is equal to 0. So here we get the remainder is equal to 0. So that it is already factor of this one. It is also factor of this one. Let us consider this as q of x. Q of x is also factor of p of x. By finding the zeros of this q of x, the zeros are nothing but the zeros of this p of x. Therefore, let q of x is equal to 3x square plus 6x plus 3. So this I want to remove. Q of x equal to 3x square plus 6x plus 3. So to find zeros, other two zeros, let q of x is equal to 0. Nothing but 3x square plus 6x plus 3 is equal to 0. How to common x? Then we get x square plus 2x plus 1 is equal to 0. 3 into x square, 3x square, 3 into 2x, 6x, 3 into 1, 3. So here 3 is multiplying, goes to that side, will become 0 by 3. 0 by 3 is nothing but 0. X square plus 2x plus 1 is equal to 0. So find zeros. X square term quotient is 1. Here the constant term is 1. 1 into 1, 1. Now split 1. That sum must be becomes 2. So 1 can be written as 1 into 1. 1 plus 1, 2. So that x square plus x plus x. 2x can be split as x plus x. Nothing but 2x plus 1 is equal to 0. In these two terms, the common term is x. Right? X plus 1. X into x, x square, x into 1, x. So write this x plus 1 as is here. X plus 1 write as is here. Plus, by what number we are multiplying x, we can get x only by 1 itself. 1 into x, x. 1 into 1, 1 is equal to 0. In these two terms, common term is x plus 1. Here x plus 1 equal to 0. A into B is equal to 0 means either A equal to 0 or B equal to 0 or both are is equal to 0. That means x is equal to 0, x plus 1 equal to 0 or x plus 1 is equal to 0. So x is equal to minus 1 or x is equal to minus 1 or x equal to minus 1. So x is nothing but 0. Minus 1 and minus 1 are the other two zeros of this polynomial. Here we get two equal zeros. So finally the zeros of all the zeros of P of x are minus 1 comma minus 1 root 5 by 3 and minus root of 5 by 3. This is about all the zeros of polynomial. If two zeros are given, if two zeros of the polynomial they given, then we can do process like this. Then we will get 4 out of 4 marks. Okay, I hope you understand this concept clearly. Thank you, everyone.